We're looking at analyzing graphs today. So in general, we can say that a function increases over an open interval. Let's focus on that for just a minute. Open interval means we're going to be using parentheses of its domain if its graph rises from left to right on the interval. So on the picture over here, this would be where it is increasing. We're looking from left to right and the graph is going upward. So a function would be decreasing over an open interval, again, an open interval, so parentheses again, if the graph is falling from left to right. So on our picture over here, that would be this area. And you could also say that a function is constant over an open interval, again, open interval, of its domain if the graph is horizontal on that interval. So that would be this little piece of the graph here on our picture. For increasing, that means that the y values of the function increase as the x values increase. Decreasing means the y values of the function decrease as the x values increase. I want to point this out here. Increasing means y's are increasing as the x's increase. Decreasing means the y values decrease as the x's increase. And for constant, the y values of the function remain constant, or the same value, as the x values increase. Okay, as I mentioned a moment ago, we read the graph from left to right the same way you would read a book. So looking at this picture over here, we're going to trace the interval of x values where the function behavior is increasing. We'll start with that, actually. So here. Increasing, as I read from left to right on the graph, this graph is going upward from here, still going up, still going up, still going up until we get to right there. And then it changes directions. So I want to describe this interval right here, and I'm going to describe this as x values, the interval of x values where this is occurring. Okay, so the x value at the beginning here is -8. So I'd start with that. I'm using interval notation here. And the end of the place where it's increasing here is an x value of -4. So I would end it with -4 there. And I'm supposed to give this as an open interval. So I use parentheses around that. Now there is another place on this graph where the function is increasing, going upward from left to right. So I'm going to trace that one as well. It's going down here, it's flat here, it's going up again over here. So I'm going to trace this part all the way to there. And then I need to list that also as an interval of increasing. So over here I'm going to use union to say that there's more to this answer. And then I'll describe the x's for this one. So this corresponds to an x value of 3. And then the end of that interval corresponds with an x value of 6. And again, it's an open interval, so I'm using parentheses there. Now I'll change colors to do the second one. So intervals where the graph is decreasing. Again, I'm going to trace it. If we determined that the graph was increasing before, it cannot be decreasing on the same interval. So I don't even need to look at the increasing intervals anymore. I'll just pick up where I left off here. So right here, I can see that the graph is falling. So I'm going to go ahead and trace that part there. And then from there to the other increasing part, the graph is flat. So that's not decreasing. So I need to describe this interval now. And again, I'm describing just the x values. So the beginning of this is at an x value of -4. And the ending of this interval is at an x value of -2. And again, open intervals. The third thing we're looking for is intervals where this graph is constant. I'll use green for that one. So I'm going to trace it. Again, if we determined that the graph was either increasing or decreasing, it cannot also be constant on those intervals. So I just need to look at whatever's left. What's left is just this little part right in here. So the graph is constant on this interval here, and I'm going to describe it as the interval of x values. So that would be from -2 to +3. And again, it is an open interval, so I'm using parentheses on that. Okay, lastly on this graph, we're going to give the domain and the range, which was our topic yesterday. So for domain, we're looking at the graph from left to right and listing the interval of x values. This graph is continuous on its entire domain, so I can just say the smallest x value to the largest x value. And then for domain and range, it does not have to be an open interval. So it's whether we use brackets or parentheses is dependent on what kind of symbols we have at the ends. This one's got a solid dot on the far left. So that's going to be a bracket for the -8. And it's got a solid dot on the far right. So that's going to be a bracket on the 6 as well. For the range, we read the graph again from bottom to top. And we're just going to list all of the possible y values. So that would be -4 to +8. And again, the symbols that we use on either end is dependent upon the dots that are on the end of our graph here. And since they are solid on both ends, both the bottommost and the topmost, it's going to be brackets on both sides. Okay, one more thing we want to look at on graphs are the local extrema, local and absolute extrema. Extrema is the plural of the word extreme. So this is talking about the extremes of the graphs. That would be the absolute highest and the absolute lowest. That's what we call absolute extremes. Local means that it's just a high point in a small little region of the graph, or a low point in a small little region of the graph. So kind of like a little bump in the graph. So looking at our graph over here, actually, let's read through the words first. When the graph of a function is increasing to the left of some value of x and decreasing to the right of that same value of x, then at that value of x, the value of f, the function value, is the largest. This y value is called a local maximum. Now, I want to point this out. It is the y value that we refer to as the local maximum. So if you're asked to find the local maximum, you would need to be listing the y value. So now if f of c, so the function value at that x value, is greater than or equal to all of the range values of f, then we can say that f of c is an absolute maximum of the value of f. And again, f of c is a y value on the function. Alrighty, similarly, when the graph of a function is decreasing to the left and increasing to the right of the same x value, then at that x value, the value of f, the function value, is the smallest. So again, the y value is called a local minimum. So when we refer to local maximums and local minimums, we're talking about the y value on the function. If the function value at that x is less than or equal to all of the range values, then we would say that f of c, the y value at that x, is an absolute minimum of the function. So we have a picture over here to look at. This is a function called g of x. They have it labeled up here. And I see on my graph that there is a little bump here. And so this little bump gives me a high point. And so my high point would be D. The local maximum is at point D. I don't know what the y value is for that one, but if I had to approximate, I'd say maybe it's about a 2 or something. So I could say the local maximum is 2. There's a local minimum. There are actually 2 local minimums. So there's one here at point F. And so I would say the local minimum value there would be 0. And there's one here at point B as well. The local minimum at that one would be some kind of negative number. I'm just looking at the y value here. So I'd say that that's maybe about a -9. Now, of these 3 that we saw here, let's look at the maximum first. This is a local maximum only, not an absolute maximum, because there are points that are higher within the range of this function. This function goes all the way up to this, almost to this open point G here. So this one actually does not have a local maximum. An absolute maximum. But it does have an absolute minimum because this point B here is at the very bottom of the graph. All right, so now we have a little bit of guided practice here. I want you to work through this entire problem, and then you can click on the video here to check it and see how you did. And then if something doesn't make sense, write it down so that you can ask me questions.